Hey everyone, and welcome to This Explainer. Today, we're going on a seriously cool journey into the structural anatomy of robots. We're going to take things from foundational theory right into hands-on practice. Honestly, by the end of this, you'll probably look at every machine around you through a completely different lens. Let's demystify robot chassis design.
Okay, let's dive right into this with a bit of a weird question. What do a house, your physical body, and a highly advanced robot actually have in common? Take a second to really think about that. You know, when we look at a house, we see the paint and the siding. When we look at a person, we see skin and clothing. And when we look at a robot, we usually just see that shiny plastic or metal shell. But if you strip all of those outer layers away, what's the unifying characteristic holding the whole shebang together? Well, let's find out.
Section 1. The robot skeleton, chassis and frame.
The answer really becomes clear when we make a simple comparison. You know, when people first look at robotics, they often feel kind of intimidated by all the wires and blinking lights. It feels entirely alien. But here's the thing. A robot actually relies on the exact same foundational principles as our own biology and our everyday architecture. Just like your bones give your body structure so you can stand upright, and a house's wooden studs support the walls and roof, well, a robot's chassis performs that exact same foundational role. Once we look at it this way, honestly, the intimidation factor completely vanishes.
So the crucial point really comes down to this foundational engineering term, chassis. A chassis is basically just the physical frame or structural anatomy of a robot. Think of it as its skeleton, or even like a protective suit. It's the core platform that absolutely everything else is built on. Because without a chassis, a robot isn't really a robot, right? It's literally just a messy pile of loose electronics and disconnected motors sitting on a workbench. The chassis is that vital unifying element that transforms all those separate parts into a single, cohesive working machine.
Section 2. The purpose of the chassis. What does it actually do? Now, what's really interesting about this is that the chassis isn't just some passive frame. It acts as a highly functional support system with a very critical checklist of jobs. First up, it supports the internal components. Every single wire, sensor, and battery needs a home. Second, it holds the robot's brain, the processors. Just like your skull protects your actual brain, the chassis provides this safe, secure mounting point for the delicate microchips that do all the heavy lifting, the calculation and decision-making. And third, it firmly secures the motors. Think of the motors as the muscles of the robot. If a muscle isn't securely attached to a bone, it can't create movement. Same thing here. If a motor isn't bolted firmly to a chassis, it's just going to spin itself around rather than driving the robot forward. The chassis grounds the entire system.
Section 3. The robot body materials, specifically found materials.
You might be experiencing a bit of a paradigm shift right about now. So often, we just assume that building a robot requires some high-tech lab filled with expensive sheets of titanium, carbon fiber, or aircraft-grade aluminum. But think about everyday found materials for a second. Cardboard, wood, plastic. These are highly accessible items that you probably have sitting in a recycling bin right now. Can a piece of sturdy cardboard effectively hold a robotic brain? Yes. Can a block of scrap wood secure a small motor? Absolutely. You really don't need expensive metals to achieve these fundamental mechanical purposes. By shifting our perspective here, we unlock the ability to engineer and prototype right from our own kitchen tables. It's a real game changer.
Section 4. Build your cardboard chassis. Let's build your own. Let's see how this builds, turning all that theory into action, step by step. Step 1. Gather your recycled household stuff. A sturdy box from a delivery, maybe some thick cardboard from a cereal box. These are your raw structural materials. Step 2. Construct your simple robot frame base. This is where you measure, cut, and maybe fold the cardboard to create a rigid platform. You are literally acting as the structural engineer here, deciding the shape and footprint of your robot's body. And step 3. Prepare the structure to hold your processors and motors. This means poking holes for zip ties, figuring out where the heavy batteries should sit to keep the robot balanced, and making sure there's a nice, flat, safe surface for the delicate brain. You are actively applying the exact same logic used by engineers designing Mars rovers, just, scaled down to a beautifully simple, accessible medium.
And that brings us to the core takeaway of our explainer today. We've taken what sounds like an intimidating, highly complex engineering concept, the structural anatomy and chassis design of robotics, and transformed it into an accessible, hands-on learning experience. We stripped away the complicated jargon and the need for expensive materials to reveal the simple, elegant truth beneath it all. A robot is really just a body built to hold a brain and some muscles. And that body can be made out of pretty much anything as long as it follows those foundational structural rules. Engineering isn't just for people in white lab coats. It's entirely approachable for absolute beginners, right here, right now.
So I want to leave you with this provocative final thought as we wrap up. What internal components will your new cardboard skeleton hold first? Are you going to attach wheels and motors to make it drive around? Will you mount a sensor so it reacts to light? Or maybe even add a small speaker to give it a voice? You understand the framework now. You know exactly how to build the foundation. The chassis is ready and waiting. The rest of the design is entirely up to your imagination. Thanks so much for joining me in this explainer. Keep exploring, keep learning, and start building.